Hi, folks. Welcome back to Physics with Captain Rod. We're going to talk about number 21 here in your Unit 3 homework. So we got Timmy standing on this giant merry-go-round thingamabob here that has a diameter of 6 meters. And let's see, somebody here, what did they do? They took a radar measurement of Timmy's speed and found that it's 4 meters per second. So Timmy's going in a circle like this, and the circle has a radius r. So the distance that Timmy travels in one cycle or one trip around is 1 circumference. And keep in mind, that's 2 pi times the radius of the circle. So that's a number you should be able to calculate fairly easily. Now, Timmy's speed, right, which remember is the magnitude of your velocity, right, is equal to distance over time. So if you use 1 circumference for your distance, you can then calculate a time, and that will be the time to go around exactly once. So part A here now, where it says what is your angular velocity, or what is Timmy's angular velocity, or I should say it says the angular velocity of the merry-go-round, right? So that's a change in theta over a change in time. And when this thing goes around once, your change in theta in radians is 2 pi. And you can, I just chatted a little bit about how to calculate your time. All right, let's look at the other questions here. How long will it take to complete 20 revolutions? Well, a couple ways to do that. Once you know the time for 1 revolution, hopefully it's fairly obvious how to get the time for 20. I guess I probably don't need to say any more than that. All right, what is Timmy's centripetal acceleration? So remember how that's calculated. Centripetal acceleration is equal to speed squared over radius. These are numbers that you have in abundance here listed up above. That should be no problem. Part D, the required coefficient of friction needed so that Timmy does not slide off. So you might want to look at this from a couple different viewpoints here. Let me talk about a top viewpoint first. Let's say here's our circle here. And let me say this is Timmy. Top view. In one, think about the different forces acting on Timmy. We would have a gravitational force, which in this viewpoint would be like in the direction we're looking. That would be down basically in this picture. Not down like this way, but what I mean by that is down like this way, pointing away from us. Then Timmy's standing on this thing. So he's supported there. There's going to be a normal force. Then ask yourself, what force is keeping Timmy undergoing circular motion? He's just standing there. He's not holding anything. Hopefully the answer to that's reasonably, hopefully it's reasonably obvious. And remember, centripetal acceleration is always towards the center of curvature. So what I would do now is kind of a snapshot from this viewpoint, from behind Timmy here maybe, and draw him, and then put all the force vectors on him. And then keep in mind that relative to the ground, right, Timmy is not accelerating up or down. That should allow you to write a force equation in the, I'll call it y direction there. And then Timmy is accelerating in the direction tangential to the ground. I guess I'll call it the x direction for now. Remember, he's accelerating towards the center of curvature. So that should get you by that. Hope that you're enjoying your homework.